Don't get caught in traffic. Don't play in traffic and stay in your lane. Today, we're going to be paying attention to exactly none of that and doing the exact opposite. I'm James Kelly from Juniper Networks. We're going to be talking about playing in traffic at high speeds in AI clusters and exactly how you manage that. Let's get into it. All right, let's take a look at our handy Terraform Abstract examples repository. If you were with me in the last demo about AI cluster topology design, you'll know that this demo is going to show you how to automate Abstra with our Abstra Terraform provider for AI clusters. Last time we were talking about rail optimized design, an NVIDIA prescribed feature, and how we make that easy with Juniper Abstra in our intent-based multi-vendor fabric manager at Juniper Networks. Today, we're going to be talking about a different part of our best practice recommended design. And last time we were looking at this subfolder of the examples. I'm going to go into this example lab of a real AI cluster that we've set up with three different fabrics or three different so-called blueprints in Abstra. And I've actually got an instance of Abstra spun up in Cloud Labs. You'll know that I mentioned last time too that you can delete and create your own topologies here. And you just at a few minutes after a click of a button, you'll have access to Abstra and be able to log in. So when you open it up in a new tab, you basically have this and it asks you to log in and it gives you the credentials right there. Also, like last time, I'm going to start off by showing you my GitHub desktop. I've just pulled down the repository that I was showing you in my browser, Terraform Abstra examples. It has all of the Juniper examples in there, and we're going to be using that one of them, of course. So I'm going to open this up in Visual Studio Code. Like last time, the first thing that I have to do is actually point my provider at my instance of Abstra. And I'm going to just copy and paste this. I had a quick note outside of the screen recording. That's how I did that so easily. But admin is the username, amazing catfish $0 is the password, and this is the IP address that you saw in the last browser tab. Let me just flash back there so that you know you can see exactly what I'm talking about. Here's the IP address. Here's the credentials. All right. So back to this. I'm just going to now save this file and take a look at what we're talking about in our blog was dynamic load balancing and how it helps alleviate congestion over regular ECMP load balancing and the possibilities of using some packet spraying in the future and other forms of load balancing. Um, As part of Abstra reference designs, those intent-based, very nicely validated designs that are laid down as a data center network fabric, we're going to be using the layer 3 routed only designs. And as part of that, it doesn't include the configuration in Junos for dynamic load balancing. If you want to learn more about dynamic load balancing, I'm going to keep the video short and ask you to go and read the details in the blog. It's also a little bit of self-promotion since I wrote the blog. I would encourage you to read it, I would hope. This is the actual very simple configuration in Junos. And if you're familiar with Junos, this stanza sort of syntax should be very familiar to you. You can change the inactivity timer in microseconds, or you can just leave it out completely and it'll default to 256. I wanted to show that to you. Also, unlike last time where we only looked at designs, I've got a blueprints file here, and this really creates the blueprints, creates some of the resources that are necessary for the blueprints. And I'm going to be applying, as I described in the blog, the configlet that was created in that other file to two different fabrics, one for my backend GPU to GPU fabric, and one for my storage fabric. Both of those are the Rocky, very high bandwidth, fairly low flow count fabrics that'll highly benefit from dynamic load balancing as compared to other kinds of load balancing. And as an example, you could apply this to all devices. We've just given this little condition in here. If you only wanted to apply it to the leaves, for example, if you had, let's say, single links between your leaves and spines, dynamic load balancing really wouldn't help you at all on the way back from the spine down to the leaf. That would be an example of how you would do that. All right, so I'm not going to go into any more about the configlet. I'll let you check that out at your own leisure. What I will show you though is that coming in here, like last time, we can, before I do this, I need to change into the right folder. And I'll do a Terraform init. We'll just make sure that I have the right version installed, the most recent version of the Apstra Terraform provider. And if I do a Terraform plan, so this is a blank slate in terms of my instance of Apstra that I spun up, it'll say that there's 58 different resources to add. And I will do a Terraform apply. And before I type yes, what I can do, I suppose, is perhaps this, just kind of split the screen here. And let's look at Apstra. And you'll remember how all of the designs showed up, for example, under the racks and the templates in the last demo that I did. This time, if we go into blueprints, you'll see that there's absolutely no blueprints here right now. As soon as I say yes here, it's going to start firing away at the Apstra API. The Terraform provider for Apstra is implemented in Go, and that uses a Go SDK for Apstra. It was also open sourced. And all of this stuff is going and just in a matter of seconds, creating 3 different fabric configurations inside of Apstra. Now, what this Terraform actually doesn't do, that we'll be adding in the future as part of my next demo as I'm going step by step through this, is additional configlets. I talked in the blog about hinting at DCQCN in the next, and then looking at some analytics. So this isn't actually going to commit anything to the Juniper Junos devices. We'll save that for a later demo, but you could see basically now that the Terraform stuff is all done, it's gone and created the backend GPU fabric, backend storage fabric, and let's now make this window a bit bigger, the front end management fabric. And if you look inside of any one of these, you'll have to come into the Stage tab, and you can see that there's certain types of resources that were allocated. This was done in that blueprints.tf file. And there's certain things, for example, like the spine and the leaf, that aren't yet actually allocated, right? So if you wanted to, for example, go and allocate those here, you could do that manually. As I said, we're going to save all of that automation for a later demo and show that to you as well. And of course, none of this is committed because for it to be committed, we have to be using real devices. I'm putting this together quickly, like I said, one step at a time. So we will get there in later demos. Stay tuned for how this actually shows up at the device level. And then you can kind of see, for example, when you see one of these Juniper devices, all of the configuration for it. And we'll take a look at how that configlet gets applied here in the next demo. In the meantime, you can see that this is the front end fabric where we actually didn't apply the configlet. So I should look at, let's say, the storage or the other one. And when I go in there, if I go into the configlets here, excuse me, you'll see this configlet here, DLB for AI leaves. That was the configlet that we provisioned, excuse me, using Terraform. All right, that concludes the demo. I hope you'll go and check out this repository. You can easily pull it down and walk through these things using Apstra Cloud Labs, and you can see how easy it is to create and automate stuff in Apstra. And stay tuned for the next step on the journey to creating and automating AI training clusters with Juniper Networks. I'm James Kelly. Thank you.